Part D. Part D asks, what's the range? A range is a horizontal question. This is a question in the x dimension. There's no acceleration in the x dimension, so the kinematic equation that we would work with is x final is equal to x initial plus velocity through time. Our x final we'll call the range out here, r. Our x initial will start at the origin, we'll call that 0. This velocity is in the x direction only, so I'm going to remind myself it's vx. Delta t, we calculated delta t. That's the time it took to reach the top. So you can substitute in whatever you found for delta t, you can substitute. It was some other term. And so delta t was established by the vertical velocity. So the vertical velocity basically launches the object in the air. That gives the object time in the air to rise and fall, and the horizontal velocity then has a chance to move along given that time that the vertical velocity is able to keep the object in the air. So it's like the vertical velocity buys time for the horizontal velocity to make some range. But what is this horizontal velocity? This horizontal velocity is proportional to the side adjacent. It is the adjacent side of this. This is called a vector triangle, but if you don't want to think of it as a vector triangle, you can just think of it as a regular triangle with the sides equal to the magnitude of these vectors. And we know the magnitude of h, it's v naught. V naught, it was a known given. And if this is the adjacent side and that's a hypotenuse, we can relate those two by the equation cos theta is equal to adjacent over hypotenuse. The adjacent side is Vx, and the hypotenuse side is V naught. These are their magnitudes. So if we multiply both sides by V naught, Vx, the horizontal velocity, is left on its own. So now we have V naught cos theta is equal to Vx. And now we can substitute that in there. So we can have an expression for range in terms of the horizontal velocity and the time. And that time was calculated by how long it took an object thrown up with that vertical velocity to fall.